Welcome back. This is part 2 of our project. We will look at what we call Wheatstone bridge of diodes. That is our part 2, whereby, remember, these diodes do not use AC current, that is alternating current, the one from electricity, but we must change AC to DC. DC means direct current, and the component that are used to change direct current, not direct but alternating current to direct current, is what we call diodes. And these diodes must be arranged in a pattern, and that pattern is known as Wheatstone bridge. Now we must make that Wheatstone bridge to make sure that now we have DC current from AC current. Now in this tutorial we will look at some schematics or some circuit diagrams, and we have also to explain them fully. For example, we have our diagram here. The diagram here is the diagram that talks about the Wheatstone bridge. The Wheatstone bridge normally contain 4 diodes. We have diodes A, B, C, and D, as you can see them. We have A, B, C, and D, as you can see them. Now, as far as I am concerned, I just want to make this assumption. I just want to make this assumption that whoever is watching this knows something about diodes, and looking at this schematic you can be able to explain, or you can be able to say which side is this, which side is the other side, as you can follow the diagram. Now, for them that may be new, this side is the positive one, the positive side. The other one, this is the negative side. Now, as you can see the shiny part, the shiny parts here. This is the negative, this is the positive side. Now, according to our schematic here, you have to make sure that diodes are arranged in this order. You solder them the way they are, and probably provide some wires for this joint, this one, and this one. You can see inside here we just let AC in, that is the electricity, and outside here the DC gets out, the direct current will get out. Remember, always this will be our positive and this will be our negative. Let me explain a bit. Why is it that when current get in here, we always have positive on this side and negative on this side? Now, assuming that remember we are talking about AC. AC is alternating current. It normally alternates. At a time, it is positive here and the other side is negative. So when it is positive here, remember, diode will always allow current to pass through it if it is forward biased. And the diode which is forward biased here is B, because this is positive and this is positive. So it will allow current to flow. When it flows, then when it gets to this point here, it can't flow this way, because C is, we have positive current here, and C, this is negative terminal. That means that C is reverse biased, and therefore our current proceed this way, that is positive. Now, when this is positive, the other one is normally negative. The current on the other side is normally negative. That is with reference to AC current. Now, when it is negative here, remember it can't flow this way because C is reverse biased. And because this is negative and our diode here D is negative terminal, this is negative terminal, this is now the way because it is forward biased, and therefore it will flow this way for us to get negative on the other side. Now remember, current keep on alternating. At that was just one instant. We can also have another instant whereby it is negative on this side and positive on this side. When negative on this side, our diode A here is forward biased, and therefore current will flow to A, will flow through A, going to the negative terminal of DC. So that is right. It won't flow through B because B is reverse biased, and so it will just block it. Now, bearing in mind that on the other side it is positive, negative, positive on the other side, that is AC current. Now, when it is positive at this joint here, remember, current won't flow to D because D is reverse biased. This is positive current, this is negative terminal, and this is positive terminal to C. So therefore, it will flow through C, and hence, when it gets to this point here, it can't flow through B because it is positive, and this is negative terminal. So therefore, it will just flow that way, through this way. Now, having understand the mechanism on how they normally work, I think now we can go direct to our project. Our Wheatstone bridge is complete. Now what we have to do is to add very important wires for the AC and for the DC. This is our Wheatstone bridge, and as you can see, these wires are the one that carries the DC power. Now you can see here we have the AC, the one to AC current to the Wheatstone bridge. Now you can see exactly what our multimeter gives us. A Wheatstone bridge has a capability of changing alternating current from, let's say, 240 to 240 AC to around that 240 DC. You can see our Wheatstone bridge is okay, working perfectly. Now we can go on and construct our LED. We can continue now to go on and do the other part of our LED. Thank you for watching. For you to get the next part or the other videos,